Hello and welcome everyone. This is Mohammad Izamam from Saimedha Ecet Coaching Center Koti, Hyderabad. Saimedha Koti, Hyderabad is providing a golden opportunity to all the Ecet 2024 and as well as Ecet 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, Saimedha Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. ర్యాంక్స్ గురించి చెప్పాలంటే Saimedha Koti Hyderabad లో every single year we have proven that maximum ranks in all the branches ECE, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous Ecet examination questions will be explained by expert faculties. My dear students, గుర్తుపెట్టుకోండి, ఓన్లీ ప్రీవియస్ ఇయర్ కాంపిటేటివ్ ఎగ్జామినేషన్ క్వశ్చన్స్ కొరకే సపరేట్ కోర్స్ ఉంటుంది, పే చేయాల్సి ఉంటుంది బయట మార్కెట్లో. కానీ Saimedha Koti Hyderabad లో ఫ్రీ ఆఫ్ కాస్ట్ we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous Ecet examination questions with which you can understand the level of teaching, the expertise which is there in the Saimedha Koti Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the Ecet 2024 and Ecet 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Now next point, the point of contraflexure occurs in, okay, the point of contraflexure occurs in. Now what is the meaning of this contraflexure actually? Okay, first let us discuss this part. What is the meaning of point of contraflexure? So point of contraflexure means, let us take one simple example over here. First let us try to take the example of double overhanging beam. Okay, if you are taking double overhanging beam, okay, this is a double overhanging beam we have taken and we are having UDL on this. What we are having? UDL. Having UDL. This UDL we have taken. Okay, I am giving the direct shear force diagram and bending moment diagram for this. What is the shear force diagram and bending moment diagram for the double overhanging beam with the UDL? Okay, now let us take this part. So if you are taking, now if you are taking this part, now let us draw the shear force diagram and bending moment diagram for this. So if you are taking this one, shear force diagram, so shear force diagram for this will be getting it as, let us take this part as this one, and this part, then this one and this part. Okay, so this is shear force diagram we are having. Shear force diagram for what we are getting over here, double overhanging beam we have taken with UDL. Okay, directly I am drawing over here. We are not having any concept for this part, means we are not interested in it. Directly whatever the question we are having, we have to remember the diagram, that's it. Okay, now let us draw the bending moment diagram over here. So for bending moment diagram, what we are taking, let us see this part. So for bending moment diagram, we are getting this part as, okay, like this, something like this. We'll be getting the bending moment diagram for this. So whenever we are having shear force diagram and bending moment diagram, now what is the meaning of point of contraflexure? Okay, what's the meaning of point of contraflexure? Point of contraflexure means whenever the bending moment it is changing its sign. Whenever the bending moment, leave this part, shear force diagram, whatever we are having, we are not concentrating on that. Now we are concentrating only on what? Bending moment diagram. In this bending moment diagram, whenever this bending moment value it is changing, means from positive to negative or negative to positive, that we are calling it as what? A point of contraflexure. Okay, so we are taking over here. So this part we have taken over here, this part, this is point of contraflexure we are having, and this is also point of contraflexure we are having. Sometimes it will be given bending moment is 0. Okay, in some cases it is also correct. Whenever the bending moment is becoming 0, that is also correct in some cases. But in the options, if it is given like a bending moment changes its sign, means that should be our first option. Okay, first preference we have to give for whenever the bending moment it is changing its sign. Changing its sign means from positive to negative or negative to positive. That should be our first preference for the options. In some cases, if that option is not given and is given the option as a bending moment is 0, then also that we can take it as a second preference. Okay. Now this is the meaning of what a point of contraflexure. Now what is our question actually? The point of contraflexure occurs in is what we are having: simply supported beam, cantilever beam, fixed beam, overhanging beam. Then directly we can say this part: in overhanging beam we are getting the point of contraflexures. Okay, but I'll give you some important points over here. First let us take this one. First, if you are taking cantilever and this is point of a contraflexure. How many points of contraflexures we are getting over here? You can remember directly. So first we have taken cantilever, we have taken, and the second we have taken it as a simply supported. Okay, cantilever and simply supported. In these two beams we are not getting any point of contraflexure, so it will be what? 0. Now next we are taking it as a propped cantilever. Next what we are taking? Propped cantilever. If you are taking propped cantilever and we are taking it as a single overhanging beam, then we are getting 1 1. Okay, in both the cases we are getting point of contraflexure. Now next we are taking it as double overhanging beam. In this double overhanging beam, and next case we are taking it as a fixed beam. For fixed beam also we are taking this part as 2 point of contraflexures. Okay, so this part we have taken. So if you are seeing this question over here, the point of contraflexure occurs in simply supported beam we are having 0, cantilever beam we are having 0. For fixed beam as well as overhanging beam we are having the point of contraflexure. So actually both options are correct. Okay, both options are correct over here. We can go with both the options. As per Ecet key we are getting the answer as a overhanging beam, but both options are correct. Now let us go for the next question. The bending moment diagram for a simply supported beam loaded in its center is. Okay, bending moment diagram for a simply supported beam, what we are having for a simply supported beam loaded in its center, means first question we have taken over here, the simply supported beam we are having and we are having the point load. So what is the bending moment diagram we are getting? So the bending moment diagram, it is looking like a triangle, but which type of triangle? Either it is right angle triangle, isosceles triangle, or else equilateral triangle. Right angle means it should be 90 degrees over there. Okay, one of the angles should be 90 degrees. We are not having any 90 degrees over here, so we can't say it is right angle. Now next, equilateral triangle. Equilateral triangle means 3 sides should be equal. So but we can see over here, this side it is equal, but this side is somewhat lengthy over here, so we can't say that it is a equilateral triangle. So if any 2 sides of a triangle are equal, then what we have to say? We have to say it as a isosceles triangle. Okay, so same diagram, same question we can take over here also, and what we have to give the answer now? The bending moment diagram for a simply supported beam loaded in its center is which triangle? Isosceles triangle. Okay, this part we have taken. Now the point of contraflexure in beams is a point where, now just now we have discussed about point of contraflexure. What we have discussed? The bending moment when it is changing its sign. Okay, so whenever it is changing its sign, that point we are calling it as what? A point of contraflexure. So the point of contraflexure in beams is a point where bending moment is 0, shear force is 0, bending moment changes its sign. So what I have told you, if this point is given, we have to go for that answer only. Suppose if this part is not given, then we can go for the second preference as bending moment is 0. Okay, so we are going for this part, bending moment changes its sign. Third option is correct. Now next point. Next question what we are having, in a beam where shear force changes sign, the bending moment will be. Okay, now what we are having over here, in a beam where shear force changes sign, the bending moment will be. Okay, now same case we have taken over here, listen carefully. In this also, now what we are having means, if you have taken this part, okay, this diagram we have taken, and we have taken one more diagram in this also. Okay, suppose if you are taking this diagram over here, what we are getting this part is shear force, it is becoming 0. So whenever shear force it is becoming 0 over here, listen here carefully, whenever shear force it is becoming 0, what is the bending moment we are getting? Bending moment is maximum. Bending moment is what? Maximum. So for this part we have taken over. If you are considering this example, so we can take shear force is equal to 0 means what is bending moment we are getting? Maximum. But actually what you have to remember means whenever shear force it is becoming 0, it can be maximum or minimum. It can be maximum or minimum. Okay. So over here whatever the values we are getting over, these are bending moment values. So over here shear force it is becoming 0, shear force is becoming 0, shear force is becoming 0, and at this point what is bending moment? What is bending moment? So if you are going for that values, we are getting one is minimum value, other is maximum value. So we can't say directly that whenever shear force is becoming 0, the bending moment will be maximum only, the bending moment will be minimum only. We can't decide that part. It can be maximum or minimum. Okay. But now if you are seeing this question over here, now listen carefully. Again in this question also, if it is mentioning maximum or minimum, either maximum or minimum, then we have to go for that option. Okay, then we have to go for that option. If that option is not given, then what we have to do? 0, minimum, maximum, negative means. So first question what we have taken, simply supported beam with the central point load we have taken. So according to that example what we are deciding, what we are assuming means whenever the shear force it is becoming 0, whenever shear force it is changing its sign, the bending moment will be what? Maximum. Bending moment will be what? Maximum. Okay, then we have to consider this part. If we are having maximum or minimum, then we have to go for that. If that is not given, then we have to go for maximum. Now next question, the bending moment diagram for a cantilever beam subjected to moment at the end of the beam is. Okay, so what we are having for cantilever beam, we are having cantilever beam we are having, and subjected to moment at the end of the beam, means we are having the moment over here. If we are having moment, so for moment what we have taken over here, for shear force it will be point, and for bending moment it will be what? Vertical line. So whenever we are getting the vertical line, so it will be looking like what? Suppose if you are having vertical line, then we are having this part now. So it will be looking like what? Whenever we are having the vertical line, so we are having a sudden change. If you are having sudden change over there, then what we have to take? It will be looking like a rectangle. It will be sudden change means we have to remember only one figure over here. Whenever we are having sudden change or we are having the vertical line, then we have to take it as what? A rectangle. So over here also what we are discussing over here, it will be looking like what? A rectangle. Option 1 is correct. Now next, the maximum bending moment caused by a large number of equally spaced identical loads on a simply supported beam. Now for this we have to discuss over here. Now what we are having? So maximum bending moment caused by large number of equally spaced identical loads on a simply supported beam, means we are taking the case as, now listen here carefully. So this is simply supported beam we have taken. This is simply supported beam and we are having a UDL. Okay, what we are having over here? UDL we have taken. So this is RA we have taken, and this is RB we have taken, and this is W we have taken. Okay, UDL part we have taken, and this complete length we are taking it as what? L. Okay, like this we have taken over here. Now first, as we have taken the first point over here, algebraic sum of all the forces means RA plus RB, it is equals to. Now this UDL part, whatever it is given, actually it is not actually the load. Now how we have to find out, how we have to convert that UDL into load means we have to take the area. So this UDL, it is also called as what? A rectangular load. UDL, it is also called as what? A rectangular load. So for rectangular, what is the area formula we are having? Area means length into breadth. Okay, so over here we are taking this part as W into L. What we are taking? Length into breadth means we are taking it as W into L. So we are taking this part as W into L we have taken. Okay, this is the first equation we are having over here. Now after that, if you are taking moments, at a point A, if you are taking moments at point A, now what we can do over here? Taking moments at point A means first we have taken this part, it is becoming anti-clockwise and this will be becoming clockwise. Okay, so for that moment what we are having over here, RB into L. So RB into L, it is equals to, Now for this part what we are having, again for moment means load we have to write first, then we have to write the length. Okay, now what is the load we are having? W into L. So we are having this part as W into L into, now what is the distance we are having over here? So distance we have to take it as a L by 2. We have to take half of this part. If you are taking half of this part means L by 2 we have taken. If you are taking L by 2, now what will happen? This 1L gets cancelled. So RB value is equals to WL by 2. RB value is equals to what? WL by 2. Now as we are having this one, RA plus RB is equals to WL we are having. Now if you are substituting RB value, so WL minus WL by 2. WL minus WL by 2 means again what we are getting over here, RA value is equals to WL by 2. So RA value is equals to RB value is equals to WL by 2. RA value, RB value is equals to WL by 2 we have taken over here. Now after taking this RA value and RB value, now what we are calculating over here, first let us calculate a shear force. Okay, shear force we are calculating, shear force. Now first point is a shear force at a point B. Okay, now what is the sign convention we have taken for shear force? Actually means whatever the load we are having, after that we have to draw the imaginary line. If you are drawing the imaginary line over here, if you are drawing the imaginary line after that load, so it is coming under which quadrant? It is coming under fourth quadrant, quadrant 1, 2, 3, 4, fourth quadrant. If it is coming under fourth quadrant, then we have to take it as what? A negative. So we are taking this part as minus, what is RB value we are having? WL by 2. Okay, or else I have already told you, whenever we are having this symmetrical loading, directly we can find out RA value and RB value. How we can find out? Whatever the load we are having divided by 2. So what is the load we are having over here? W into L. W into L is the load divided by 2. Okay, so WL by 2, like that we have taken. Now let us calculate shear force at a point A. Shear force at point A means what I have told you. Shear force at point A is equals to what? RA for simply supported beam. So which is equals to WL by 2. Okay, this point we have calculated. Now let us try to find one more point over here if you are taking the middle point. Before that, let us go for bending moment. So if you are going for bending moment over here, bending moment. So bending moment at a point B. What I have told you, bending moment at point B is equals to 0, and bending moment at a point A, it is also equals to 0. Okay, at the end supports whatever we are having, that bending moment will be equals to what? 0. Okay, this part we have taken. Now let us take one more point over here. Suppose if you are taking at the midpoint, if you are taking this point as C, what we have taken? Point as a C we have taken. So let us try to find out a shear force at point C. So what is shear force at point C we are getting? Now let us see this part. Point C means we are having this one. Okay, this is RB we are having. This is RB. This is a load we are having, and this part is what? L by 2. Okay, this part is L by 2 we have taken. Now if you are considering this, part as a UDL, okay, we are having this part as a UDL, and this part is, we are taking it as W. Okay, this part is W we have taken. Now let us find out at a point C. At point C what we are having? So this part we are taking it as minus W by 2 we have, minus WL by 2 we have taken. Next, as it is in the downward direction means we are drawing the imaginary line. Yes, so it is coming under quadrant 1 only. If it is quadrant 1 means plus we have taken. Then what is the load we are having for this? Load is equals to WL by 2. Okay, what we are having? WL by 2. So plus WL by 2 minus WL by 2 means it is equals to 0. So shear force at point B is equals to minus WL by 2. Shear force at point A is equals to plus WL by 2. And shear force at point C means at the middle, what we are getting the answer? 0. Okay, so this one we have calculated. Similarly, if we want to calculate bending moment at point C, what we are calculating? We are calculating bending moment at point C. So now let us try to convert this part. So if you are trying to convert this part means this is RB we are having over here. This is RB, and this complete length is L by 2. Complete length is what? L by 2. And this UDL, if you want to convert into point load, that UDL what we are doing over here, if you want to convert into point load over here, then what we are doing, we have to multiply this part. So this will become W into L by 2. Now what is the distance we are having? If this complete part is L by 2, now what will be half of this part? half will be, this part will be L by 4 and this part will be L by 4. Okay, like this we have taken. Now let us do this part also. So bending moment at C means first we are taking this part. So it is positive. What we have to take? A positive. So if you are taking positive, RB value how much we are having? WL by 2. Okay, this part we have taken, and up to point C means what is the length we are having? L by 2. We are having L by 2. Okay, now next point. For this we are taking minus over here. Okay, for this we have taken minus because it will be like sad face. So we have taken over here. Now what is the load we are having for this? WL by 2, and what is the distance we are having over here? L by 4. Okay, we have taken this part. Now let us calculate this. What we are getting? WL square by 4. Okay, WL square by 4 minus WL square by 2 4s are 8. Okay, like this we have taken over here. So if you are taking WL square by 4 minus WL square by 8, now what is the LCM we are getting for this? Okay, what is the LCM we are getting means 4 we have taken, 8 we have taken. So 8 will be getting the 8 as answer. So let us take this part as, this part is 8 we have taken, and next part will become what? 2WL square minus WL square means WL square. Okay, so this is the value we are getting over here. So bending moment at point C, it is equal to WL square by 8. Okay, so this part we have taken. Now after getting all the values of shear force and bending moment, let us try to draw the diagram over here. What is the diagram we are getting? What is the diagram we are getting for the shear force and bending moment? Okay, now let us take the shear force over here. So if you are going for shear force, now shear force at point B is equal to what we are getting? Minus WL by 2. Minus WL by 2 means like this we have taken. This is minus WL by 2. We are having the point load. We have taken vertical. Okay, minus WL by 2. Now for shear force at point A, we are getting WL by 2. Okay, this part we have taken it as a WL by 2. Okay, now next shear force at point C means we are getting 0 over here. Okay, 0 we have taken. Now whenever we are having UDL, for UDL what we have to take? For UDL we have taken what over here? For UDL, shear force is inclined line. Similarly for this part also we have to draw inclined line over here. So if you are drawing inclined line, so this is shear force diagram. Okay, this is shear force diagram we have taken. So this is negative part we are getting, this is positive part we are getting over here. And this is what we are having over here, minus WL by 2, this is 0, and this is what? Plus WL by 2. Okay, this is shear force diagram. Now let us try to draw bending moment diagram what we are having. So if you are having bending moment diagram, now what will happen? Bending moment at point B, 0. Bending moment at point A, 0. Bending moment at point C. Bending moment at point C means how much we are getting over here? WL square by 8. WL square by 8. So now for UDL, bending moment diagram what we have to draw over here? Parabolic. So if you are taking parabolic over here, okay, so this part is parabolic, like this parabolic we have taken. So this part is 0, this part is 0, and this maximum, what we are getting over here? Maximum bending moment. If you are getting maximum bending moment, then what we have written over here? WL square by 8. So the maximum bending moment caused by a large number of equally spaced identical loads on a simply supported beam is WL square by 6, WL square by 8, WL square by 16, WL square by 24. So what we can go with this option over here means WL square by 8. Okay, second option is correct.
So my dear students, for Ecet 2024 and Ecet 2025, Saimedha Koti Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi Saimedha Koti Hyderabad in this very week, guys. In this very week only, we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద Saimedha Koti Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous Ecet examination questions. I wish you all the best. This is Mohammad Inzamam signing off.